Adna ma'am, are you here?
Yeah, I'm there. I'm here.
Yeah, I have just sent you a message.
Yeah.
Mr. Tarun had joined, so I asked him for some more time. So he said he'll join after 5 minutes.
Yeah. 10:30 will start exactly.
Hi Aruna ma'am.
Hi, Tarun. How are you?
Yeah, I'm good. Yeah. So if everything is ready, can we start?
Just students are joining. So we have told them that it is 10:30.
Okay, no problem.
Okay. 2 more minutes. Let us wait, and then we can start.
Sure, sure.
Students, please switch on the camera. Anya, are you here?
Yes, ma'am.
Yeah, okay. You have to switch on the camera, okay?
Okay, yeah, ma'am. I'll just connect from a different device. 1 second.
Okay.
Miss Lenny, are we good to go?
Yeah, it's all good from my side.
Yeah. So students, numbers. Right. Let us start now. Good morning, everyone. It's my pleasure to introduce our guest, Mr. Tarun Aitam, a young entrepreneur and design thinking coach. He is an alumnus of IISCR, Indian Institute of Science Education and Research, Pune. He is a mathematician by training. He started teaching at 16 and founded Science Station TV at the age of 19. His mission is to bring university level research based teaching at school levels. He had worked with Dr. Vijay Bakhtar, a Padma Bhushan awardee. He is a team leader of Param supercomputer. And he had also worked with Professor Ramanujam, who is at Indian Institute of Mathematics and Science. He had spoken at various platforms addressing students and working professionals around with diverse topics like entrepreneurship, game theory, business strategy, and mathematics. Here we have Mr. Tarun with us to take us through mathematical anxiety. So let us listen to him and learn from him. Thank you. Over to Mr. Tarun.
Yeah. Hi students. So this will be an interactive session. So I'll just pose some questions and I look forward to your perspectives around these questions. So my first question is, what is mathematics according to you? What is your personal idea of mathematics? If any of the students wishes to answer.
Yes, Agastya, you can answer.
I think mathematics is it's like the study of it's what we it's like solving sums and like how to like get to like it's like sort of logical thinking because you have to find the answer to like an equation or a problem.
Okay, so is mathematics all about problem solving?
Like it might be like mathematics is not only about problem solving, but it's about understanding the problem as well.
Okay, is it just about understanding problems and solving problems, or do we have something else?
I think we have something else, but I don't know, sir.
Okay, that's a good response. Yeah, I think Suhas wants to respond. Yeah, Suhas, please go ahead.
Sir, what I think about mathematics is like everything that we can see or tell is some way or the other can be explained using mathematics somehow. I don't know how, but it can be somehow. And like Agastya said, it is a form of logical thinking, and there are mathematics in almost everything you see. Like in a notebook, you might do some math problems. In a Rubik's cube, right next to me, there are specific algorithms which has a lot of math in it. The dimensions of a book,
Okay.
basically everything, anything that can be explained can be explained through mathematics. That's what I think.
Okay. And Suhas, who's going next?
Agam? Agam, you can ask your question.
Ma'am, I've
Agam?
not raised my hand, ma'am.
Okay, okay then.
Okay, so before moving into more serious mathematics, I have a okay, how many of you like soccer here? Would you want to raise your hands? How many of you like soccer?
Sir, 1 minute. Sir, 1 minute. Children, I think all of you need to turn on your cameras. Please turn on the cameras, please. Okay, now you can answer the question as well. How
Yeah,
many
so
of you like soccer? Yes, sir. Sorry for the
yeah,
trouble.
just two of you? Okay. Okay, three of you. Oh, that's four. Okay, five. Okay, seven of you. Fine. So now let's say you're taking a penalty kick. Okay, you're taking a penalty kick, and do you think there is mathematics applicable there? When you're kicking the ball, there's a goalkeeper who's trying to stop the ball. So do you think there's mathematics applicable there? Would somebody want to answer this?
Ved, would you like to give a try?
I don't think.
You don't think?
I
Okay.
can be wrong, but I don't think mathematics is.
Okay. Family? Sanvi, you raise your hand. Would you want to answer?
No, I raised my hand because you asked me.
Okay, so who wishes to answer this question? The others can drop your hands. If anyone wishes to answer the question, you can raise your hand. Can we apply mathematics in a penalty kick?
Sir, I think, yeah, Agam, yes, tell.
Yes, I believe that we can apply mathematics as the angle you hit the shot in or the speed you hit it in. It is science and maths. So I'm not sure which one it is. And there's a lot of psychological play in it as well. Logic comes into play as well, whether you should do that or whether you should do it on the side or which side, I don't know.
Okay, thanks, Agam. Anybody else wishes to answer it?
I think Kushak, you can go unmute and talk, Kushak.
Okay, ma'am. I think that the speed and the time by which the ball will reach the goalkeeper or the goal, and the angle and the distance we have to take in our kick, that all matters. I think, and that comes.
Okay. Do we play mind games while taking that kick? Do we play mind games? Yeah, Samit?
Yes, we have to make choices also, like which side should we kick. We are like we think that which side should we kick. Should I kick that side? When the goalkeeper catches the ball, will it hit properly? And how fast should I hit it?
Yeah. So my question
that
is,
all we
would you
think.
play mind games with the goalkeeper? Would you play mind games with the goalkeeper?
Sometimes we do, like we pretend that we are kicking to the right side, but we actually kick on the left side. Sometimes that also happens.
So do you think there is mathematics involved there?
I think no. I don't think so.
Okay. Now, I'll tell you one interesting story from mathematics before moving into algebra. I thought today I'll discuss about algebra and show you how algebra can be interesting. But before that, I have three little stories for you guys around mind games and mathematics. So in case you guys wish to play good mind games and win sport, right? Agreed, now we don't get to play so much sports, but wherever there's an opportunity to play mind games, mathematics comes in handy, and I'll show you how. I'm sure, I mean, some of you would be watching the IPL. So this is a story, I think, 2 years back or 3 years back. So there was this uh, batsman called Alex Hales who used to play for Sunrisers Hyderabad. So he was batting. And so what he did was, even before the bowler bowled, he moved this side. He moved this side and he was holding the bat this way. So what would the bowler assume? The bowler would assume that the batsman is going to hit it this way, right? Because he's already moved this way. So the bowler assumed that the batsman is going to hit it this way. And Alex Hales is one of the best T20 batsmen in the world. So what did the bowler do? The bowler bowled the ball here, far away from the batsman, because he thought the batsman is going to hit here. Would anyone want to guess what the batsman actually did?
Can I guess?
He just moved side, so it became a white ball, I think.
Okay. That's a good guess. Anybody else?
Can I try?
Yeah.
I think what he did was that he literally just changed the position of the bat and hit it the other way.
Exactly. That's what Alex Hales did. He moved aside and hit it this way for a six. Why would he do that? Why would he go this way and then hit the other way? Yeah, Ved.
To trick him, to trick the bowler.
Right. And the bowler's name is Avesh Khan, and he's just coming in from under 19. So they thought, okay, he's a kid. Let's play around with him. Let's smash his confidence. And Alex Hales did this. My second story, again from cricket. My third story is from soccer. Second story is again from Sunrisers. So there was this batsman called Rishabh Pant who was just hitting every bowler out of the ground. So, and people didn't know what to bowl to him. So what happened is there was this bowler called Siddharth Kaul who was bowling. So there was one fielder at the back who was protecting one shot which Rishabh Pant plays. Like, he just lifts his bat this way and the ball goes back for a six. And people were just laughing at that shot. Just he touches the ball and it goes for a six at the back. So there was a fielder at the back. And what Siddharth Kaul does is he removes the fielder. There was a fielder kept to stop that shot, and Siddharth Kaul removes the fielder. Would anybody want to guess what ball Siddharth Kaul bowled?
A spin.
Anybody else?
Answer?
The normal ball, so that it would go six behind, like.
See, why did he remove that fielder? Earlier there was a fielder because if he bowls the ball here, if he bowls the ball near the chest, Rishabh Pant would hit it back. If he bowls the ball to the chest, Rishabh Pant would hit the ball back. But now he removes the fielder. Why would he remove the fielder?
Because he wasn't throwing at his chest. He was throwing
Okay.
somewhere else.
Okay. Would
Yorker,
anyone...
I guess.
Sorry?
Yorker.
Okay. Would anyone want to guess what Siddharth Kaul did? I said it's a mind game, so guess it.
A bouncer?
Mind ball.
See, he removed the fielder and he told Rishabh Pant that, hey, I'm not bowling at your chest, right? By removing the fielder, he's effectively telling Rishabh Pant, I'm not bowling at your chest, right?
He threw the ball at his chest.
Exactly. That's called a double bluff. You bluff as though you're not going to bowl there, and then again you end up bowling there. So Rishabh Pant felt like a fool. He was just laughing. And any idea what Siddharth Kaul did the next ball?
No.
He bowled the same ball again. Would anybody expect that he would repeat the trick twice?
No.
No. That's why he did it.
Exactly. So do you see the value of learning to play mind games and sport?
Yes, sir.
You could play these mind games in badminton as well. Pretend as though you're going to smash and just drop it, right? So now in case the other player is very slow, Would you smash or what would you do? You're playing badminton, the other player is very slow. What would you do?
You would drop.
You try to hit it far away from the player. No? You try to make that player run, right? So there again, you can play mind games, right? Pretend as though you're going to make that person run, but hit it at him or at her. The person is ready to run and then it comes straight. Would that be easy?
No, sir.
Never.
That's a double bluff, right? You bluff as though you're going to hit it far and then you end up hitting it straight. So this subject which I'm talking about is called game theory. So in game theory, what we do is we study games. And what's a game? In a game, we've got players and every player has some moves. And as per the moves, there are outcomes. Every player has got moves. And as per the moves, there are outcomes. So it's a very interesting field of mathematics, which is called game theory. So mathematics is not just about numbers. Mathematics, as I think quite a few of your friends have said, it's about logical thinking, right? Even this is about logical thinking, right? So we draw tables and we analyze the possibilities. And this is used in law. It is used in political science. You know, you want to understand what the government is going to do, what is the opposition going to do. Again, you can do game theoretic analysis. Game theory completely changes the way you look at the world. So those of you who find mathematics to be boring, it's my little appeal. Give mathematics a chance. There are a lot of interesting aspects of mathematics. One has to just go and discover them. So now I wish to talk a bit about algebra and show you how algebra can be very exciting. Okay. Now, I want you guys to tell me, I mean, since all of you are home, can somebody switch on your video and show me something in your house which doesn't change at all every day? Show me something which doesn't change at all.
I have something that changes every minute.
No, I want you to show me something which doesn't change at all.
Sir,
Yeah.
it's that wall. This never changes. It stays in the same position.
Okay, your wall never changes. Okay,
Sir, the
great.
house structure.
Fan.
Yeah, you show it to me.
Fan.
Okay, your fan never changes. Okay, great. Anybody else?
Light.
Okay, fan, light. Samit, I think you've given some answers. Anybody else? Can you show me something which doesn't change? Yeah.
Sir, wait.
The door.
Okay, the door doesn't change. Okay.
Sir,
Anybody else? Yeah.
the hand with the Rubik's Cube in it.
Okay, so that doesn't change.
Well, I guess it does.
Is it? Wait, it changed the very next second.
Oh yeah, it does actually change the next second. I just need to turn it.
Okay. Anybody else can? Yeah.
The curtain.
Sorry.
The curtain.
The curtain. Okay, great. Now, can you show me something which changes every day?
Sir, I change every
Okay, your Rubik's Cube. Okay, very smart, huh? Okay, next.
Eyeballs.
Sir, I change every day.
Eyes.
Oh, you change every day. Okay, brilliant. Anybody
Sir,
else?
hair.
Your hair.
Specs.
Okay.
Summer specs.
Sorry.
Glasses. Specs.
Okay, your glasses change every day.
Yes, sir.
Yeah,
I
they
take
do.
them off
Like
at
they
night,
get
then
dust
I
on the
remove it sometimes.
A pencil.
Okay, you mean the position of the glasses, is it?
Clock.
Sorry.
the hand
pencil.
The clock changes. Okay, the time on your clock changes.
A pencil changes every day when you sharpen it.
Your pencil changes every day. Okay.
and then it just changed.
Okay, your bottle changes. Okay, so do we have more things which change or do we have more things which remain the same?
Remain the same.
More things
There's
are.
no things that change in my house.
Then more things that change because like house also changes if you move inside the house, right?
Right. So now you're talking of your house, but in general, if you talk about the world, do we have more things which change or more things which remain constant?
So the whole world changes every single second.
Yeah.
So we more things which change, right?
At any second there could be a new album that comes out.
No, right now, exactly right now, the earth
Rotation
is
and
rotating
revolution.
very small. Yes, sir.
Okay. So I want any three of you to tell me what your mother tongue is. What's your mother tongue?
Mine is Telugu. Telugu.
Sorry?
Mine is Telugu.
Okay. Telugu. Sorry?
Mine is Telugu.
Okay. Telugu and then Tamil, is it? Okay. Any other language speakers apart from Telugu?
Sir, my mother tongue is Hindi.
Okay. Telugu, Hindi, and any other language speakers here?
Gujarati.
Gujarati. Okay, great. So now I'm going to tell you about another language. And this language is the best language which can explain nature. You know what this language is?
Animal language.
Sorry, animal language. Okay.
Is it math? Because that's the topic.
Smart, huh?
Is it sign language?
Okay. So mathematics is a language, and mathematics is considered the queen of sciences. You know what is the beauty of mathematics when used as a language to describe nature?
Everyone understands it.
Sorry?
So you can use equations and all to explain things like.
Everyone can understand it.
But a lot of people are scared of mathematics.
Sir, coding language that also has maths, right?
Yeah. Coding language can be understood.
Explain everything.
Yeah. So, in fact, if you study ancient Sanskrit scriptures, all the mathematics, science, and all concepts written in Sanskrit, they don't use normal Sanskrit. They use a special form of Sanskrit called Navya Nyaya. That is modern logic. So, when we try to study technical topics, we need a language which has precision. Precision as in the meaning has to be exact. So, mathematics helps us get that precision, right? So mathematics is a fantastic language. And now in mathematics language, to describe things which change, we have these fellows called, to describe change, what do we have? Variables, right? And to describe things which do not change?
Constants.
So you've got variables, you've got constants. So you said there are more things which change and less things which do not change. So what would then be more important, variables or constants? What would then be more important? Yeah.
Variables.
Okay. Now, when you were in second, third class, you learned how to work with constants, right? You learned how to add numbers, how to multiply numbers, how to subtract numbers, and so on. But then probably only in sixth grade or seventh grade, you're getting to learn how to add variables. Why are you taught that very late? If variables are more important, why are you taught variables so late?
Because we need to
Without
first
constants, we can't.
find out how to. We need to learn the basic things.
Right.
Without
Can
the
I say?
basic,
Yeah. Can I say that constants are like a tricycle and variables are like a bicycle?
Yes.
Do we learn a tricycle before a bicycle?
Yes.
Yes.
Okay, great. So we come up with this branch of mathematics called algebra, which deals with things which change. And see, algebra deals with two kinds of quantities. One, things which change, and two, things which are constant but unknown constant. Unknown constants. So now let us say on chat, now let us say I send a secret code to one of your friends. Okay, I send a secret code to one of your friends, and you guys do not know that secret code. So is this a constant or is this a variable?
Variable.
But it doesn't change, right?
Constant, unknown constant.
Exactly. So is unknown constant a variable or is it a constant?
Variable.
Constant.
It's still a variable. You'll probably call it an x. So that's a little abuse of notation here. That's a little abuse of notation here. When we look at x, y, z and all, we refer to both unknown constants as well as variables, as well as things which change. Right. Now, let's look at addition of variables. Now let's learn mathematics as though we are the ones who are inventing mathematics, as though nobody taught us mathematics, right? Because did God come to Newton's dream and tell him, beta equation note kar lena, physics aisi chalti hai. Was that how it happened? Did God come to Newton's dream and tell him, please write these equations down, this is how physics works? Or did we discover them?
So he discovered it himself out of curiosity.
Exactly. So if Newton can do it, we can do it too, right? So now let's try to discover laws of algebra on our own, as though nobody ever taught us. So now let's say I've got an x. So what is an x? X is an unknown constant or a variable, right? Let me consider x to be a box. It's a box of chocolates. How many chocolates? I unfortunately do not know. It's a box of chocolates. Now, if I talk of x plus x, so what would x plus x then mean?
X plus x would be 2x.
No, but what would it mean in this interpretation? If for me x is a box,
it would be 2 boxes.
Correct. What would 5x mean?
5 boxes. But we do. Wait, I have a doubt.
Yeah.
You said X is a box of chocolates. How do we know if you just said the box of chocolates is so since box is like 1, so then X would be equal to 1. Why do we need like multiply and stuff?
That's a very good question. That's a very good question. Now, your the units which you're using here is chocolates. You're using chocolates to measure stuff. You're not using boxes, right? You'd want your answer to be reported as chocolates. How many chocolates? So when you say X chocolates is like one box of chocolates. But how much is one box? I unfortunately do not know.
Okay, I understood.
Does that answer your question?
Yeah.
Okay, great. So when I say 5x, what does 5x mean? See, even before we answer a question in mathematics, it's important for us to make sense of that question, right? So what would 5 into x mean? What is the meaning of multiplication? What is the meaning of multiplication?
Repeated addition.
Repeated addition, right? So what would 5 into x then mean?
Will be x plus x plus x plus x plus x.
Correct. So in our story, what would it mean?
5x.
Box plus box plus box plus box plus box. Right? Now, if I ask you what is 5x plus 8x, what would your answer be according to our story?
5 boxes plus 8 boxes.
Right. Now, if I ask you what is x into x, what would you tell me?
Sir, probably we'll tell xx or maybe x square.
X square.
Why would we call it x square? I mean, how would we imagine x into x? X is a box, but how would we imagine x into x?
So we'll imagine it like the number of boxes there are, the number of outer boxes there are. So the number of boxes are in the other number of boxes.
Okay.
1 into 1. Because x is equal to 1 box, then it's 1 into 1.
Okay.
Can we take a different value for x instead of 1? Can we do 2? Because if you do 1 square, that's still gonna be 1. That's not gonna change at all.
Okay.
So if you do 2, however, it would become 4, 3 would become 9, and 9.
Okay. Yeah, are you guys able to see my screen?
Yes, I can.
Okay. Now,
Yes, sir, we can see.
Can I visualize x into x to be this way, where this is x, this length is x, and the width is also x. Can I imagine it to be a square with both length being x? For example, this would be my 2 by 2 square, right? Can I imagine x square to be a grid? This is my 2 by 2 grid. And this would be a 3 by 3 grid, right? So can I imagine x square to be an x by x grid? And why, if you say yes? Can I imagine x square to be x by x grid?
Yes.
And why?
Because if x is equal to like 7, and then you keep another, and then you multiply, and you said x square, so it would be 7 times 7, which is 49. So like there would, and there would be 49 squares in like tiny squares in the entire square. So x, so if x times x would be x square, so like, since x is equal to 7 in this case, it would be like 49, so x square. I don't know what I just said.
Okay, great. Now, if I ask you what is x plus 2 into x plus 4, how would you try to find an answer on your own, as though nobody ever taught you x plus 2 into x plus 4?
I have a doubt.
Yeah.
I already know how to do this, so trying to unlearn that would be difficult.
Well, the real learning is in the ability to unlearn and relearn, right? So how would you give a proof for that? You know a method, but how do you prove that method? Or rather, the first question to ask is, what does x plus 2 into x plus 4 even mean? Can I have a story to make sense of x plus 2 into x plus 4?
If x
So
is
basically, you can do like this.
Yeah.
Suppose there's a box. I'll take that story only. There's an empty box, and now you're adding 4 chocolates to that box.
Okay,
So
that is your x
then
plus
same
4.
thing. X plus 4 into what was the other equation?
X plus 2.
Yeah. So then you're taking another box, empty box, and adding 2 chocolates to it. Then you're
Is it
just
empty? If
multiplying
it's empty,
both
is
of
it
them.
x? If the box is empty, is it x?
Yes.
Are you
Like the
sure?
box already has few chocolates, but so it's X. We don't know how many. So it's X. So then we
Is it
just
empty or is it x?
so
Is it empty or is it x?
He already
it's
has
X.
chocolate.
It a box is there. It has few chocolates, but we don't know how many.
Exactly. So that's your x. And you're adding 2. Fair enough.
Yes, sir.
And you have another
And you're
box,
adding
you're adding 4.
yes, sir. Same thing. And then you are just multiplying both of
So
them.
what would this multiplication mean? I want a story so that I can make sense of this. Can someone come up with a story for 2 into 3?
there is 2 chocolates and there's another 3 chocolates on this side, so if you just
That is 2 plus 3, right?
no, like 2 and then 3 on this side, like on the same chocolate bar thing, and then that's
There are
it.
2 chocolates, and then there are 3 sets of chocolates which have how should there are 3 boxes with 2 chocolates each.
Great. Or can we say that there are 3 friends and each friend has 2 chocolates? Would that be more intuitive?
Yes.
Okay, great. So now can I extend this story to x plus 2 into x plus 4?
Yes, sir. So the X friend, something like that.
Okay, x friends and 2 more
X
friends join in.
friend, X friends are there. So they all have few chocolates. I mean, we don't know how many friends are there. They're X friends, and then then we give 4 chocolates. And then same thing with the other set, but with 2 chocolates.
Okay,
To
anybody
those
else?
X friends.
Okay, anybody else wants to try? Anybody else wants to try?
Children, give it a go. Even if it is wrong, it's okay. Yes, Agastya.
Yes, sir.
Yeah, would you want to extend this 2 into 3 story to x plus 2 into x plus 4? So
2 into 3 into x plus 2 and x plus 4.
So 2 into 3, you said 2 are chocolates and 3 are friends, right? 3 friends having 2 chocolates each. So can I extend the same story to x plus 2 into x plus 4?
I don't really know.
No, but you said 2 is chocolates and 3 are friends. So can the same story be transferred here? So x plus 2 would be?
X plus 2 would be like x plus 2 would be the chocolates.
And x plus 4 would be?
The friends.
So when I say x plus 2 chocolates, what would it mean?
That mean like a number which is not known plus 2 is the chocolates, and a number and like the exact same number plus 4 is friends.
Great. So can I build a story? Can I build a story and say there are x students who are at school. There are x students who are at school, and there are 4 students who are at home. Okay.
Yeah.
X students at school and 4 students at home. There are x chocolates in a box, and you have got 2 loose chocolates.
So there's x chocolates in the box, and there are like 2 loose chocolates.
Right. Now in this story, how many? And every student gets a box full of chocolates as well as 2 loose chocolates.
Every student gets a box full of chocolates as well as 2 like regular chocolates.
Yeah. So what is the total number of chocolates distributed in the school? I mean, total number of chocolates distributed in all.
In all, so every student, even the ones at home, right?
Yeah.
So that's 6 boxes of chocolates and 8 loose 12 loose candies, because each student gets a box and 2 loose candies. So I just multiplied by you can just add 2 plus 4.
Okay, let's remove x and let's take a number here.
Okay.
Let's say there are 6 chocolates in a box and 2 loose chocolates. Let's say there are 20 children in a class and 4 children at home.
There are 20 children in a class, 4 at home, and x is 4 chocolates, right?
6.
6. So in all, everyone gets 8. So 20 into 8, 160.
24 into 8, no?
No, 24 into 8. Yeah, sorry. At first I thought 24 into 8.
192, right? So yeah. Total number of chocolates is 6 plus 2. Total number of students is 20 plus 4.
Yes.
So total number of chocolates is x plus 2. Total number of students is x plus 4.
Okay. So yeah, I get that now.
So now x plus 2 into x plus 4, x plus 2 into x plus 4 is the total number of chocolates distributed.
Yes.
So now, what is the total number of box chocolates distributed at school?
Box chocolates.
Box chocolates at school, not the loose chocolates. Let's say the loose chocolates are, blue.
Yeah.
Loose chocolates are blue, and the box chocolates are green. What is the total number of green chocolates given at school?
Green chocolates, there are 2. So 4 at school and not at home, right? Just the ones at school, right?
Yeah.
20 into 2.
20 into 6, no?
So didn't you?
I said green.
So you said green was the loose 2 chocolates, and you said blue was the box chocolates.
Are you able to see my screen?
Yeah, I'm able to see your screen, sir.
Yeah, so box chocolates are green. I've written green here, no?
Yes, and there's 6 box chocolates, right?
Yeah.
Oh, at first I thought you said blue was green and green.
That'd be 20 into 6, no?
120.
Yeah. In the case of x and x, what would be the total number of green chocolates at school?
Green chocolate at school, x and x.
X square?
X square.
What is the total number of blue chocolates at school?
Blue chocolates at school is 20 into 2, 40.
40. In this x story?
In this x story, I think it's Sir, I don't think I know, sir.
Two blue chocolates to each student and x students. Yeah. 2 blue chocolates to each students and x students.
2x.
Great. What is the total number of green chocolates at home?
Green chocolates. Green is the box chocolates, right?
Yeah, box. There are x chocolates in the box, and there are
24.
There are x chocolates in the box and 4 students at home.
4x.
Okay. What is the total number of blue chocolates at home? 2 blue chocolates.
Blue chocolates. 8.
So would this be a proof for how you learned x plus 2 into x plus 4?
Yeah.
You said x plus 2 into x plus 4 is x into x plus 2. plus 4 into x plus 2, right?
Yeah.
What is x into x plus 2? X into x plus 2 is the total number of chocolates at school. X is the number of students at school, and x plus 2 is the total number of chocolates. 4 is the total number of students at home, and x plus 2 is the total number of chocolates.
Yeah.
So the idea here is to see a proof. Whenever we learn any method in mathematics, if we can try to find a little story through which we can see a proof for it, we develop our logical thinking. So now a simple question for all of us to ask. A simple question for all of us to ask ourselves is, would we want to learn mathematics in a robotic way? Or would we want to learn mathematics in a human manner?
Human.
Yeah, so what would that mean? So can we see a proof for it? Can we get a story to, because when we can pick up a nice little story, mathematics would appear more like common sense. Mathematics would appear more like common sense than like a set of procedures or processes to be learned. Would somebody want to just explain the story again? Would somebody want to explain this x plus 2 and x plus 4 story again, just so that I know if you guys got it or not? X plus 2 and x plus 4 story.
Sir, I had a little confusion in that.
Okay, I'll repeat this. Yeah. So let me clear this. Let's say I've got X students at school and 4 students at home. I've got X students at school and I've got 4 students at home. X students at school, 4 students at home. And say I've got X chocolates in a box and 2 chocolates loose. And the box chocolates are green and the loose chocolates say are red. So I've got 2 red chocolates and X green chocolates. So what is the total number of chocolates here? X green chocolates and 2 red chocolates. So what is the total number of chocolates?
X plus 2.
Okay. So total number of chocolates is X plus 2. What is the total number of students?
X plus 4.
So X plus 2 into X plus 4 is the total number of chocolates given, right? To all of them?
Yes, sir.
It's kind of like 20 into 6. 20 students, each student getting 6 chocolates.
Okay.
Total
Okay,
chocolates
now
into total students.
Okay, now I understand, sir.
Total students into total chocolates. Now this problem I can break it by solving it into 4. I can break it into 4 parts. I can count the number of, this is the students at school. These are the students at home. Students at school, students at home. So how many green chocolates are given at school? X students at school, X green students, so X
Yes,
square,
sir.
right?
X into X. Yes,
Yeah.
sir.
X students at school and 2 red chocolates. So how many red chocolates at school?
Sir, 2x. Like each student will be given 2.
Yeah. Now,
So 2x.
X green chocolates, 4 at home. X green chocolates, 4 students at home. How many chocolates? How many green chocolates at home?
4x.
Now, 4 students at home and 2 red chocolates.
4 into 2, that's 8.
Right? So X plus 2 into X plus 4 is X square plus 2X plus 4X plus 8.
Okay, so now I understand it.
Now let's do one thing. Let's change the numbers a bit. Let's say I've got 8 red chocolates. And let's say I've got Y students at school and I've got say 7 students at home. Now what would be the total number of chocolates? How would we do this problem?
We still have X green chocolates.
Yeah, X green chocolates, Y students at school, 7 students at home, 8 red chocolates.
Yes, sir. So what we can do it. So the number of chocolates, it will be x plus 8.
Okay.
And the number of students is y plus 7.
Correct. But I want to find the value of x plus 8 into y plus 7. How do I do that? With this story, with this grid, how can I find the value?
So first, okay. So each child at school is given. Okay, wait.
Correct.
Yeah.
Each child.
So each child at school is given x green chocolates.
Correct.
So that is x into y, xy or yx.
What is xy? Xy is the number of
chocolates given to the each person at school.
Each or all?
All children in school.
All chocolates or only one kind of chocolates?
So one kind, which are green chocolates.
Okay,
like
great.
a box.
Great. Next.
Next, 8 red chocolates are given to every person, all students at school. So that is 8 into y. So that's 8y.
Okay. Next.
And then at home also we do the same thing. So there's 7 students at home. So so all of them get x green chocolate. So that's 7x.
Okay.
And then 8, so there are 7 students at home and 8 red chocolate is given to you. So that's 7 into 8, that's 56.
Excuse me, sir.
Yeah.
Sir, I studied this kind of table in my Vedic math book.
Okay. Yeah. So, but the most important thing is, are we just following the table or what are we doing here? What is the most important component here?
So we are making a story and then solving the question. We are understanding and solving.
Right? We're trying to invent the method on our own, right?
Yes, sir.
So in Vedic maths, do you create the method or do you follow the method which is given to you?
Create the method, sir.
You create the method? Okay, then that's great. So yeah, so that's fundamentally what I wanted to show, that by trying to ask some questions and by trying to imagine stories, you can actually create your own methods. So whenever there's some aspect of mathematics which gets problematic, you can create your own method and then you can try to come up with a proof over why your method is correct. We might make a lot of methods, we might design a lot of methods, but they may not be right. So we could think of a proof to check whether a method is actually correct or not. Okay. So now see, mathematics is like a mind gym. The more mathematics you do, you're training your mind to think logically, to think in a structured manner. But then if we were to just accept procedures, if we were to just accept procedures the way they are, we may not tap into the full potential of mathematics. We may not be able to enjoy complete mathematics. So when you eat an ice cream, do you enjoy it completely or do you just chew it or gulp it very quickly?
I never gulp down ice cream really quickly. I get brain freeze.
Okay. So, but let's say you're eating something which you do not like, then what do you do?
I eat it as fast as I can.
Okay, so you can't feel the taste, is it?
Sir, I actually eat it very slowly so that it just, so that after a few bites the taste gets out and it seems normal to me. I eat that thing first very fast and then I am free to eat my favorite stuff.
Acha, acha, great. So likewise, what I'm saying is mathematics can be seen with proofs. Mathematics can be done in a very creative manner. Once you look at mathematics in a very creative manner, as though you're inventing your own methods, you're actually enjoying the complete mathematics, like enjoying that ice cream. You're traveling through it, and then what happens is later on, even if now let me tell you a little story again. So while doing x plus 2 into x plus 4, we connected it to 2 into 3, right? Why would we want to connect it with the 2 into 3 wala question? Why would we connect it to 2 into 3?
Better?
Why would 2 into 3 be better for understanding?
It will basically help us create a story, then we can use that same story for an equation question, like for an equation question.
Exactly. Now, what I'm talking of right now is called transferability of knowledge. transferability of knowledge. You're able to transfer the knowledge from one situation to another situation, right? And it's interesting to do this. And in mathematics, what we do is we do something called problem reduction. We reduce a hard problem into an easier problem. We reduce a problem which is new to a problem which we already know. It's like we reduce our bicycle problem to a tricycle problem because I know tricycle already. Like our x plus 2 into x plus 4, we reduced it to 2 into 3. We understood 2 into 3, and from there we went to x plus 2 into x plus 4. Now, how would you use problem reduction in different scenarios? Now, let me give you one example from the world of business. Now, there was this guy called John Scully who used to work for Pepsi. At the time, Pepsi was losing to Coke. Even now it does, but at the time it was losing quite badly, and Scully was trying to rescue Pepsi. So at the time there was black and white television. So all the advertisements which were made were in black and white. All the advertisements were in black and white. So color TV was just coming in. And they wanted to put good advertisements on TV. They wanted to be better than Coke. Pepsi wanted to be better than Coke. But the existing ad filmmakers would only make ads in black and white. So if you were John Scully, what would you do? You want to make a better ad than Coke, and then there is color TV coming in, but then your ad filmmakers understand black and white. They don't understand color that well. So what would you do?
So first of all, we would pay them. We would like give them funds to invent the color TV faster.
No, the color TV is already there. You don't have the filmmakers. You don't have the ad filmmakers. The color TV is already there. You don't have the ad filmmakers to give you those colorful ad films.
Just try and make it yourself.
But you may not make a great video. You only know how to make Pepsi.
So at least we'll try, right?
At that time, you didn't have those many cameras. You didn't have this iPhone and stuff. Oh, by the way, Scully was one of the first marketing heads of Apple. He quit Pepsi and then joined Apple later on. So what would you do? Your ad filmmakers do not know.
So can I answer?
Yeah, please.
So instead of supporting that company, I'll join Apple.
Apple was very new then. It was in a garage.
Oh, and Steve Jobs used to work in a garage.
Yeah, Apple started in a garage. Some of the best companies in the world started in a garage. Yeah.
Wouldn't we take help from them? Wouldn't we take help from them and pay them later?
But who would you go to?
Apple.
No, Apple was not making films. They were making computers in a garage. You need an ad film, right? Whom would you go to for an ad film? You change your question. Yeah, sorry.
The film industry.
Why would you go to the film industry?
Because if your ad people are not don't know how to do it, there's at least someone who would know.
Okay, can you say that the film industry is always ahead of the television industry?
Yes, I guess.
So why do we say the film industry is ahead of television industry?
Because everything, if for example a movie first gets released in like the cinemas instead of the TV. That's just an example.
So what is the main difference between film and television from an audience point of view?
A television is smaller, theater is bigger.
Is it just about the size?
And the quality is better. They're ahead. They are ahead. Like now that I think about it, they are actually ahead.
So the best talent is making films, right?
Yeah.
So if you're Scully, you'll probably go to a filmmaker and say, I want you to make a movie. Just that your movie should be 1 minute long, not 3 hours long.
I don't think he'll agree.
Yeah. So that's what Scully actually did. So he reduced his problem to another problem. He reduced his problem of making an ad, to a 1 minute feature film. He changed the problem so he could solve it. Let me give you another example, and this one of problem reduction and this one from cricket. So, Sunrisers Hyderabad has this bowler called Bhuvnesh Kumar. So for those of you who do not watch cricket, let me, de-jargonize it for you. So he bowls this Yorkers. What's a Yorker? The ball is so low that if you try to hit it, it goes under your bat and you're out.
Sir, it is also known as a toe crusher.
No. Not every Yorker is a toe crusher. Yorker which you throw on the toes is a toe crusher, and I think it's Malinga who bowls them. Very few bowlers bowl a toe crusher, as in it directly lands on your toes. You don't remove your legs and your toes are gone. So, but not every Yorker is a toe crusher. Okay. Anyway, for the others, Yorker is a ball which is very low. So it's difficult to hit this ball because it's very low. It goes under your bat. So Bhuvnesh Kumar, what he does is he bowls this very low ball and he also bowls it far away from the batsman. So you sort of got to do gymnastics to reach out to that ball. So it's far away from you and it's also very low. It's difficult to play. Now there is AB de Villiers was batting. He knows that the problem is difficult. The problem is new. So what should he do? If there's a problem which is hard,
he turned it into an easy problem.
Exactly. So how will he turn that into an easy problem?
He could shift forward so that the ball is not that far away from him.
He could go closer to the ball, is it?
Yeah.
That's what AB de Villiers does. He goes to the ball and then falls down and hits it. So the ball is far away from him. What does he do? Say, it's like
the problem and solved it.
Sorry?
He made it into an easy problem and solved it.
Exactly. So in mathematics, the world's greatest mathematics teacher, is this person called George Polya. George Polya, Polya. So he said, if there's one problem which is hard, there's another problem which is easy. Find it. If there's one problem which is hard, there's another problem which is easy. Find it. So those of you who found this approach interesting, you can read this book called How to Solve It. This will teach you problem solving skills. Problem solving not just in terms of maths problems, but in general, any life problem. You're in a supermarket, you're trying to pick up something. How do you solve a problem there? How do you come out faster? How do you search something easily? These kind of problems you can learn to solve them by reading this book called How to Solve It by George Polya. So now I'd like to take questions, but in conclusion, what I wish to say is mathematics is not just about numbers. Mathematics is a very creative discipline. Mathematics is an art. Mathematics is as creative as music, as painting, as dance, or any of the other art forms which you might be interested in. But it's just based on how you see it, right? So, and mathematics can be useful in terms of seeing patterns, in terms of understanding the world better. So whether you're an artist or whether you're a scientist, or no matter what you wish to do in life, mathematics can be really helpful in terms of showing you the world in a better way. So mathematics is like a very nice glass which you can wear, and through that glass, you can see the world a lot more clearly, right? So that's what I wish to say. Now I'm happy to take some questions.
Yeah. Students, can you all switch on the videos? Switch on the videos, please. And it's time for question hour. You can put your questions to Mr. Tarun. Yes. Any questions? Other than solving math?
I don't have a job.
Yeah, go ahead.
Who is that? Please go ahead.
Agastya.
Ma'am, I don't have a doubt. You just asked me to turn on my video, so I turned on my video.
See, if there is no doubt, you can ask for some, other information which you would like to know. And if
sir, at one point, were you ever like anxious about math? Like, were you ever worried about math at one point?
Worried about math as in?
Like when if you were a kid, like about to write an exam, like for math, were you ever like anxious, or were you feeling like confident?
I think ever since 4th grade, I was quite confident with math.
Thank you, sir.
So, and that was because I would try to, reason things for myself. I would not memorize formally, but I would try to reason things out and I would try to explain it to different people. And that's how I always felt mathematics to be easy. And to be honest, I think before my maths exam, I would study social studies because the textbook was too fat.
Okay, sir. Thank you.
Yeah.
Sir, I have a question.
Yeah.
So, are you the founder of Science Station?
Yeah.
Thank you.
I have a theory.
Yeah.
I made in math class.
Yeah.
Like today, around like an hour ago, like an hour and a half ago. So like on a Rubik's cube, like if you do any sequence of moves, any sequence, it would eventually return to its solved state.
Okay.
So like I made a formula about it. I just wanted to check for a second time
Okay.
if it's correct or not. S as in the solved, as in solved state. A as in the algorithm, like whatever sequence of moves, and X is the number of times I repeat it. So S is equal to A times X. Would that be correct?
Sorry, can you go again? A is the algorithm.
No, it goes like this. S equal to AX.
Okay.
What that means is S is the solved state, A is the algorithm, and X is the number of times I repeat it. So technically, if I X, so like if I do.
What would multiplication of algorithm with X mean? What is the meaning of that multiplication?
So like the number of times it requires for that specific algorithm to repeat.
Algorithm, right? How do you multiply an algorithm? You can multiply a number, but how do you multiply an algorithm?
Like
so
the number
that counts to the algorithm in loop.
Like the number of times I do it. That's what I mean by multiplying.
Are you talking about the algorithm or are you talking about the number of steps in the algorithm?
No, I'm talking about the algorithm itself, how many times I have to repeat it. That's why I was multiplying.
Okay, but why would you repeat the algorithm? You would use the algorithm once to solve it, right?
No, that's not like that. Like if you like on a solved cube, if you do any sequence of moves repeatedly, it will eventually solve itself. I made a formula on that.
Okay, so the same move, if you repeat it a given number of times, it comes back. Yeah, that's right. So these changes are periodic functions. They're periodic. As in, if I repeat this move an X number of times, you come back to the same state. So yeah, your formula would be correct. So in case you find this interesting, you can actually read this thing called group theory in mathematics. Group theory. So whatever you're talking of, you'll find some interesting connections in this branch of mathematics called group theory.
Yes, sir.
Okay, no questions from girls? Here. Yeah. Mr. Tarun, can you please give them some tips to get away with this mathematical anxiety?
Yeah. So as I've mentioned in the talk that maths is a creative discipline, much like music, dance, or arts or anything. Try to think of some creative stories to interpret whatever you're learning in mathematics. Try to come up with a story for everything you do. Like today I showed stories for algebra. If you're able to think of stories for whatever you do, and if you're able to teach your friends using those stories, I think that's a great way to make mathematics very simple. So I think the best way to overcome math anxiety is to be creative in the way you learn it and to logically reason each and every step, not just blindly follow the steps, but to logically reason why we've done whatever we've done. Yeah. So would any of the students want to tell what are your takeaways from the session? So I know what was your experience. Would somebody want to tell what are your takeaways from today's session?
I got two takeaways, sir.
Okay.
One, math explains everything. Two, my theory is correct.
Great.
Right. Anyone else?
So I found this that math is present in everything you do, almost everything you do, and math is not only about numbers. Math can be learned by connecting it to something else to explain it.
Okay.
Sir, I basically understood that math is a science.
You understood that maths is a science. Okay, interesting.
Doyle, what is your takeaway?
Excuse me, ma'am. I was actually outside. I came like a few minutes back. I didn't know what. Please explain.
Doyle ma'am was asking, what did you learn from this session?
Well, ma'am, in the starting, I actually learned about the mind games, like sir was saying. And I am a sports person because I do play many sports, and I have experience with mind games.
Okay.
So I have learned a few more mind games, like sir was saying, to use them more in other ways. At first, I just used to use them while I was talking with someone I don't like, and now I can use them in sports as well. So, yeah, it's pretty
So
big.
literally it is everywhere. That's what
Yeah,
you're
it's
saying, right?
it's pretty much everywhere.
Yes, yes, yes. Thank you, Mr. Tarun. That was a very interesting session. As we all know, maths is one of the toughest subjects, and many children dread it. I hope Mr. Tarun made some difference, and he'll be able to help in some way to take your math journey forward. Now I have Ms. Anya Rao to give the vote of thanks. Anya, are you here?
Yes, ma'am.
Yes.
Can you hear me?
Yes. Can you switch on the camera, dear? Should I put a pin on you?
Yeah, I switched it on.
No.
Okay. First of all, I'd like to start off by saying good morning to everyone here, to the teachers, to Mr. Tarun, and all my friends and students here. And I'd like to, on behalf of my classmates and friends, extend a very hearty vote of thanks to you, Mr. Tarun, for gracing us with your opinions today. Um, your efforts towards mathematical anxiety and the way you explained mind games and how you gave us a different perspective on algebra and how you taught us that math isn't just about numbers was it was very eye opening. It was really nice to hear, and I think also now all the tips you gave us about like how to form a story if you ever come across a problem that you are unable to solve, make it into a story. It makes it so much more easier, and I think that tip will really help us um, in the near future. And also your examples using sports, I think lot of my friends and I really connect with sports. A lot of us like sports, so your examples using sports were really nice. I was just a little offended that you didn't use Virat Kohli anywhere in those cricket examples. I mean, he is one of the greatest players of all time, but it's all good. And I just like to say that you opened a new world to us. Like, we think about math differently now because it's not just about trying to solve problems, not just trying to about finding numbers, but it's about logical thinking. It's about finding things. It's about understanding things as well. Yeah, so once again, I'd really like to thank Mr. Tarun and our CEO, Mr. Arup sir, and our principal, Ms. Shamali, our CA coordinator, Ms. Aruna, our respected teachers for organizing this event for us. And thank you so much, Mr. Tarun, for being with us today. Thank you.
Thank you so much, Anya. I think one of the biggest takeaway for me, I am also one of those people who never liked math. So I would prefer English or science any day. So I think one of the biggest things that which left a mark in me is that every problem can be minimized to smaller problem. So I think that is a life lesson as well, because this is where everything can be divided and then it can be made into a smaller problem. Thank you so much, Tarun. When we were first told that you will be coming for it, I did a little bit of research, And of course, your TED Talk came up. So I was teaching 12th graders some time back, and this was, they had opted for science. And whenever I ask what is your ultimate aim, most of them will say IIT. Now, when I saw that TED Talk, I was really curious as to why you turned down two of the most prestigious institutions in India, IIT and IIM. Children, his TED Talk is there. Do make it a point to go through it. Do maybe we will take it up in the English class as well. So thank you so much. And it was a pleasure having you here. And we also enjoyed I especially appreciate the fact that it was a very interactive session. Thank you so much.
Yeah. Thank you, Ms. Lenny. Thank you, Aruna.
Children, that's the end of the session. You can leave. Thank you, sir.
Aruna ma'am, you're on
Thank you,
mute.
sir.
Thank you, ma'am. Bye, ma'am.
Right.
Thank you, ma'am. Bye.
Thank you, children. Bye.
Thank you,
Go
ma'am.
and
Thank
join
you,
your
sir.
classes next class.
Thank you, sir and ma'am. Bye.
Thank you, sir, ma'am. Bye.
Tarun, it's pleasure having you here. Thank you so very much for accepting our, request. And it's been a great journey for our students, this 1 hour journey. And thanks a lot once again.
Yeah, thank you.
Bye-bye. Look forward to meet you someday.
Sure, sure.
Thank you.